Here we have two identical circuits, and we want to establish the direction of current flow in these circuits. So one way is the conventional flow theory, which says it goes from positive to negative. So if we follow the direction, it will go in this manner. So that is the conventional flow theory. Here, if we use the electron flow theory, it goes from negative to positive. So current will come this way through our load. All right. In the conductor, there's a direction of current, and perpendicular to the conductor is a field. All right, you can see in both circuits that there's a field around the conductor. Now, we're to establish the direction of field about a current carrying conductor. How do we do this? We've got conventional current flow and electron flow. So how do we determine the direction of the field? We want to establish the direction of field about a current carrying conductor. Well, there's two rules. There's the right-hand rule and the left-hand rule, depending on the direction of current flow. In this case, conventional current flow, we want to use the right-hand rule. And electron flow, of course, we want to use the left-hand rule. Now, there's a couple notes. The thumb points in the direction of current flow, and the fingers point in the direction of the magnetic field. All right, so first we'll use the right-hand rule for conventional current flow. And you can see, if I were to wrap my hands around, the thumb is going to point in the direction here, right? And the fingers wrap around like that. So therefore, the direction of the field is that way. Now, if I want to use electron flow using the left-hand rule, again, I establish thumb and curl my fingers. Notice the direction. So the direction of the magnetic field would be this way. Notice in both they are the exact same way. So it doesn't matter if we use conventional current flow using the right-hand rule or the electron flow using the left-hand rule. The only trick is to remember, if you're using conventional current flow, make sure to use the right-hand rule. If you're using electron flow, use the left-hand rule. And the other tricks are to remember these 2 points. If we wanted to take a cross-section of a conductor, it would look like this here. And if we want to establish, looking at it straight on, which way the current is flowing, we can use an arrow as a guide to draw it. So if the current flow is coming towards you, it's like the arrow head is coming straight at you. And if the current's flowing, it's going away, then it will look like an X, and that would be the feathers of the arrow. So we still want to establish direction of a field about a current carrying conductor. So again, we have our current carrying conductor, and of course, the field would be perpendicular. So I know the drawing sort of looks a little bit skewed like that, but they would actually be perpendicular to the conductor. Now here we have a cross section of the conductor, and we established before that current flow coming towards you is going to have the point, and current flow going away would be the back of the arrow, or the crosshatch here. So using the right hand rule, we want to get the direction of the field. So if it's coming out towards you, the thumb is pointing the direction of the current, the fingers are pointing the direction of the field, in which case, like so. Now over here, we're pointing in. So you can see that my fingers are pointing this way. So the direction would be this way. Now, if we're using the electron flow, we're going to use the left-hand rule. In which case, this one here is pointing out. So the direction will be this way. And here, the current is going in, so the direction of the field will be this way. Now, if we look closely at these two fields, we can see that they're in opposite directions. So the fields are opposing each other. All right, so here we have two conductors, and we'll say the current flow is going away. So using the left-hand rule, we can see that if we're going in, the thumb's going to point in the direction of the current, and the fingers will point in the direction of the field. We can establish that the field direction is this way. Now, if we were to expand the magnetic field, it would actually look like this. And the direction of the field would be this way. So instead of pulling apart, they would be coming together.